first session, automated configuration of firmware. Hopefully you guys will find the topic quite interesting. At least you have found room 3. Everybody else is wandering around figuring out which room is which at this point. So we might have some stragglers come in. My name is Michael Arnold. I'm a principal systems engineer with the Apollo Group, and we will go into some wonderful topic here. On our agenda today, I'm going to go over who I am, who I work for real quick, some of the tools that are usable for firmware configurations, an example workflow that we use at our company, specifically around our Hadoop clusters, some example code. There will be links to all of the URLs for all these various tools and whatnot at the end, as well as a link to this presentation, so you don't need to drop furiously down all these examples and things of that nature. This presentation will be online shortly after this talk. And then we'll have some time for questions after that. Am I loud enough in the back? Awesome.
It's a little out in the hall, which you want me to do.
Okay, yeah, let's see. Well, it might quiet down here in a minute. Yeah. So the who. Who is the Apollo Group? We are an education company, and we are probably best known as the University of Phoenix, one of our primary subsidiaries. We have lots of other subsidiaries as well as universities across the globe. We are an international company. We have schools in Great Britain, BPP, schools in Mexico with ULA, in Chile with UNIAC, and in Canada with Western International University. So we are both an online and ground school, and we have we're out there definitely in making our presence felt, hopefully to change education for folks like yourself. Myself, I'm a systems administrator. I'm definitely into automation. I hate doing things more than twice. I'll write a script or something to make sure that it gets fixed. And with Puppet nowadays, that becomes so much easier to write up code to automate my deployments. I've been doing this about 13 years professionally in IT. I am a Hadoop Cluster admin. That's my current focus. The ability to do large clusters of machines, it helps out when you can automate those. Just trying to manually do dozens of machines, it's horrible. Did that the first time, learned from it. I tend to deal with the hardware, specifying the hardware for our environment. Firmware, heavily into that, configuring it, making sure it's at the right levels to do what we need. Operating systems, automation, deployments, and then the Hadoop application as well. Now I know the very first question that most of you might be asking is, what does firmware have to do with Puppet? We're at the PuppetConf. Is Puppet involved in any of this at this point? Not really for what I'm going to show you. There's a possibility that you could be writing some modules to, for example, configure your hardware RAID controller. That's definitely a possibility, but at this point I'm going to show you how to do things to your hardware before you have your OS deployed and before Puppet gets involved. So the tools. What are some of the tools that are available out there? Hardware vendors do provide toolkits. These are the ones that I've found out there. I'm heavily familiar with the HP Smart Start scripting toolkit. I've been using that for several years now. We are mostly an HP shop, so we deal with the HP toolkit. I managed to do an eval with some Dell hardware within the past year, so I located their Open Managed Deployment toolkit. It's very similar to the HP toolkit. And then I figured, let's see what Google can tell me, and did a search and found that IBM has a server guide scripting toolkit, and Fujitsu has their server view scripting toolkit that appear to be very similar to the other two that I have experience with. So I don't know much about the IBM or Fujitsu offerings other than they seem to be doing the similar things. If your hardware vendor isn't listed here, you can always talk to your vendor, to your VAR, and see what they offer. I'm not saying these are the only things that are out there. just the ones that I am aware of at this point. What do these tools provide? They basically have a built-in boot environment and tools that will allow you to configure your mainboard's BIOS, your baseboard management controller, the DRAC, the ILO, or whatnot that the vendor calls it, the hardware RAID controller, and fiber channel HBAs. Anybody here boot from SAN? This will let you basically tell that firmware, here's the worldwide name and the LUN that I need you to boot from programmatically, so that you don't have to manually configure that yourself. These toolkits, they tend to work by getting yourself a piece of hardware that you're going to call your reference machine. It's got the firmware in it, the HBAs and whatnot in that machine. Console into it, put your video on there and then your keyboard. Manually configure the BIOS the way you want it to be. And then you're going to capture that configuration. You're going to boot into one of these toolkit environments, utilize those tools to pull off the BIOS configurations into a file, save that file off onto your network somewhere. And then when you have other machines come in, you'll basically boot into that toolkit environment and clone the configuration onto those machines. Now these toolkits tend to come with a kernel and an initial RAM disk, plus their firmware tools specific to that vendor's hardware. There are also some requirements that you need in order to do this booting. You'll need a DHCP server and TFTP server so that your Pixie network booting will work. You also need an NFS server because not all the tools, all the firmware, all the configurations don't get shipped in that RAM disk. You need to pull them off across the network. So you'll have to have those services up and running and available for the toolkit to function. Some workflow examples. So we're going to assume in this example that your hardware, the ones that you're going to clone, is racked and cabled. Your switch ports are up and running so that your Pixie booting will function properly. We're going to assume that your server is manually powered on for this example. So whoever's doing that hardware work just hits the power button and walks away. We're going to assume that the firmware defaults, as shipped from the vendor or whatnot, are going to allow you to boot off the network if there's no other boot device found. So if there's a boot sector on those disks, if you're reusing a piece of hardware, we're assuming that that boot sector is wiped clean and that you'll, by default, boot off the network. And in this example, I'll have a single constraint that we're only talking about one vendor's hardware for this example. There are ways to have multiple toolkits involved. With your workflow, depending on how your systems are set up, you might have to have a discovery phase before you boot directly into a vendor toolkit. So something like a tool like Razor that says, hey, I'm an HP hardware, tell the system to change the TFTP boot parameters to boot off of the HP toolkit. I'm a Dell, and change the system to boot off of a Dell. We're going to assume, for simplicity's sake, that the default boot on that Pixie network is going to be just the HP tool. The process then, once that toolkit is up and running, for the workflow that I work with, is that we'll update firmware. We will do a hardware discovery, make sure if there's a RAID card in there, we'll do the RAID flashing and configuration, etc. We will configure that firmware then on that system, all that firmwares that are found, and then we will register with our build system. So you can do a callback to whatever you have, if you have Cobbler, if you have whatever else is out there. I'm going to be showing Cobbler because that's what we're using in our environment. Real quick, I will show you a video of this happening. This is your standard verbose Linux kernel boot, so don't worry too much about trying to read all that. When the toolkit cuts over, when the kernel passes over control to the toolkit, We will see some of that flow that I was talking about. You'll have your standard driver load. We'll have a discovery of some basic hardware platform information. This is built directly into the HP Toolkit itself. The NICs will get configured, and we'll get our IP address. And then we'll mount our NFS server. All of this is built into the toolkit itself. Once that NFS server gets mounted, all of the extra bits, the toolkit itself, the binaries get pulled over into a RAM disk on the target system. And then we pass control over to the install_hadoop.sh. This is the script that I have written that will do the actual work now on the system. The rest of it's just prepping to pass over control. This could be as simple as executing bash so that you can poke around and see what you have available, do that capture bit if you need to, or do the full automation of updating firmware, configuring it, etc. So we're in this custom script at this point. There's a few more modules that need to be loaded, and those get pulled in. And once that happens, we'll do the NFS mounting again, but we'll not only mount the a read-only NFS share here, we will mount a read-write share, because we tend to save all the logs from this process back to the NFS server, the discovery of the hardware, etc. We make good use of that in our CMDB. And then we go to the firmware update piece. This takes a few minutes in our example, even for a system that's up to date. It'll do the standard HP firmware scanning, check to see what components are there, check to make sure that they're up to date with the components we have on that NFS server. And here it's saying that everything is okay. We don't have no need for flashing, or it would go ahead and flash itself. And then we have a pause, just to make sure all the firmware is doing what it needs to. Some of the documentation for the HP sum command indicates that the system will reboot at this point, but on the hardware that I've dealt with, I have not yet seen that. If so, the toolkit will come back through this process, check to see if there's any firmware to flash again. If not, pass through control at this point. The next section, when it comes up, will go by real quick, and I'll try and stop it. And I'm not good at video editing, so this is the raw screen capture from start to finish. The piece that'll flash by will be the discovery step. After the firmware is confirmed to be at the right version, it'll discover, make sure it's got all the hardware that's available, do some configuration based upon the hardware type, and then we get into the part here where we actually configure that firmware. So most of this whole section up here is the conrep program from HP, which configures the mainboard BIOS. We see that it discovers the system type, the firmware date, etc. This is the BIOS knowledge file, I guess you could say. It's kind of a set of hints, this XML file, so that the conrep program knows where what structures are in this particular version of BIOS. And then this .dat file here is the actual captured configuration that's being applied. And we see it get loaded and applied. It hopefully tells us we have a return code of 0. And then it passes on control to doing the BMC configuration, which is not terribly verbose down here. It pauses, makes sure that everything's up to date, goes ahead and registers with our Cobbler OS deployment installation with the Cobbler register program, and then it goes ahead and reboots. It's fairly simple, hands-off once you get it tuned in. So from there, going back over the workflow from what you just saw, Your DHCP server sees an unknown system, and I call it an unknown system. It's never seen that MAC address before. And it defaults to booting from, in our example, the HP Smart Start Scripting Toolkit. That toolkit gathers hardware information, CPU, RAM, and whatnot, via discovery mechanism. In our custom script, it says if this is truly HP hardware, we're going to update our firmware, configure our BIOS, configure the ILO, configure the RAID if we have any. In that example, we didn't have a RAID controller. It's going to register to our cobbler server. We have hardware profiles set up for that. And then it's going to reboot. From that point, and that was the end of that screencast you saw, in our workflow, we will still manually modify our cobbler profile. And we give that entry and IP address, a host name, and which OS and some metadata to build off of. That part could be automated if you wanted to, just automatically deploy whatever profile. We still do it manually. We're not big enough to have to worry about all of that just yet. So at this point, your DHCP server has an idea of what that MAC address belongs to. It's a known system. It'll boot off the network at this point, boot into your OS installer, install the operating system. This is where Puppet comes in and will install Puppet for us. Do anything else we have in our Kickstart post install and start making money for us. Some example code I'll go into here in a second. Your TFTP configurations. This is an example for the Dell Toolkit. You can go through and read through Dell's awesome documentation. The problem is there's lots of it. And this is basically distilled down what I've found that is needed for a proper TFTP configuration. There's some standard kernel variables that get passed over, the size of the RAM disk, etc. But then you have your share location. Where's your NFS server, your IP address, and the mount point. You can tell the toolkit, yes, this is an NFS type, give it some options to share, and then which scripts do you want it to call. This is where you can pass in your custom script and some other variables that we use in our cobbler deployment. This is an example for the Dell toolkit. The HP toolkit here is fairly similar. You've got some standard boot parameters that the toolkit wants to have. But then you also have your NFS related bits and your custom script to be called. So they're very similar in that regard. When you want to capture your configuration, this is some of the code that you might run from, for example, a bash shell. You could even automate this piece if you really wanted to. But to capture the configuration, Dell wants you to definitely be in the toolkit directory on the RAM disk. And then they've got some scripts for you that will run your BIOS capture, dump it out to a file. Your RAID configuration off your PERC controllers, dump that out to a file as well as your DRAC configuration. Once you have these files on the local system, just SCP them off or read-write mount to your NFS server, push them over, and save them there for when you need to clone onto new systems. Now, in our evals, we had a RAID controller that wasn't Dell branded with Dell firmware. It was straight LSI. So if you do get one of those, you can always install the megacli command line tool from LSI, and then grab the RAID controller configuration out to a file as well. HP has a similar setup. Once you get a shell on your toolkit, change to the toolkit directory. The conrep program does the BIOS capture. We'll be seeing more of this here in a minute. HPACU scripting does the RAID controller. There are two different fiber channel HPA configuration tools. Depending on if you have Emulex or QLogic, they'll capture that configuration. HP HP hardware, there tends to be two different versions of the BMC. There's the high-end ILO, ILO 2, ILO 3, now there's an ILO 4 out. And there's also the lower-end low 100. HP has a handy tool that will take a discovery file of that system and let you figure out, do I have an integrated lights out? And if so, automatically you can just run the ILO capture tool. Otherwise, it will run the low 100 capture tool. Just an example of a way that HP has different tools that will let you programmatically figure out, do I have this hardware, then do something based on that. So we saw in the screencast there was a quick little show of platform detection that's built into the HP toolkit. You get the hardware name. There's a Pliant DL380G5. You get serial number, architecture, and they give you some shorter versions. The L name that doesn't have spaces in it, so you can do pattern matching in a case statement, for example. And we'll see more of this use here in a moment. These are some of the variables that are available then in that environment. The toolkit will set a lot of this stuff for you. And I'm giving these here as examples because in some of the code here in a moment, in the next few slides, we'll be using these. It's a good idea to have an understanding of what exactly these variables are. So for product name, you'll get the full product name of your HP hardware. Serial ID will be your hardware serial number of that main board. Product L name, the space removed version. The S name is just dropping Pliant. I'm not sure why they want to do that, but okay, it's a variable available. You've got variables for the mount point of your NFS share. This, I believe, is your read-only mount. The IP address of your NFS server, that can be handy. You need to set dates or do other things talking directly to that machine. And basically a file that they save the discovery of the hardware on that machine into. So that install underscore Hadoop.sh script. This is the one that we basically customized. HP had an example script that basically showed a lot of the workflow that we were that could be possible in that toolkit. We took that and made it work for our environment. It basically has a section near the top where it figures out which hardware is in the machine and sets a server name variable based upon that. That'll be the Pliant whatever string. And then there's a big case statement in there where we basically just set a bunch of variables so that we can call them later on with the actual, flash my firmware, do my firmware configurations. So based upon the hardware models, there's different things that you would do, there's different components. And in here you can basically set, here's my BIOS configuration file for DL160, here's the ILO configuration file for that. If you have an SL170, same thing, but here's the helper XML file to help conrep program figure out what BIOS structures are in there, those sorts of things. So it's basically just setting some variables for your command line that you will pass on to the tools later on. These are two of the more simpler hardware configurations. This is an example of a DL360. Same idea with the BIOS configuration file, but we have a little bit of a logic in here that says, if I have this version of hardware RAID controller, I want to use this file to configure it. If I have this particular version discovered on the machine, we'll use that configuration file. So you have your options and availability to change up based upon what's in that hardware. And then we have our ILO configuration variable. These variables are just based upon the program that will be executed here in a moment. This is where all the magic actually happens, based upon all those variables that get set. We do the firmware configuration. It's a real simple matter of once we've determined what hardware we've got, which file to use, bam, let's just apply that configuration. It's done. You didn't have to muck around with putting your console on there and moving through all of the menus to set that one variable you really need. The middle section here is the RAID controller. I've added a section that clears that controller. if you have a logical device already created with several disks and you want to rework that to change a RAID 5 to a RAID 1 or whatnot, you got to make sure that those physical devices aren't actually associated with a logical device. So we simply clear the configuration on the RAID controller, and then we actually flash the configuration we want on there. And in the section on doing the BMC based upon which variable is set. Simple enough. This section is registering with our build system. Now the HP toolkit and the other toolkits don't actually come with the cobbler program, but the example is any sort of API call you can make. You can curl a web service. If the curl program isn't available, you can kind of hack it in place and basically push out an announcement saying, hey, I'm done. Set me up for the next state of things. So it is pretty flexible on the platform, as long as you can get the right binaries that work with the glibc, etc., and tools that are available. This is a quick example of that RAID controller configuration. I wanted to include it because it took me forever to figure out what this little command here does to clear said configuration. Also, this is an example of the RAID controller for the E200i. It's just a text file. The BIOS configuration files on the HP platform are XML, so you could, in theory, just modify them by hand, create them by hand. I found that to be error-prone. It's far easier just to fire up your machine that might be in your lab and configure it the way it wants and capture that configuration than trying to do it manually. Because error handling, if you get it wrong, and in our example code, we don't really have a lot of error handling in there, but you need to be able to capture your failures, basically. We've recently figured out that when you reuse hardware, adding a user to the ILO that exists currently will cause that whole configuration to fail. So you can either clear the ILO configuration completely, or do one section that tries to add that user and have another section that adds all the rest of the configuration. So you've got to be careful of errors. You've got to be careful of your firmware versions. Trying to apply a capture file from version 5 of your BIOS to a version 6, that might not work because the firmware structures might have changed. So testing, check for errors and whatnot. Those are definitely some good things to do. In summary, the workflow basically of these tools tends to be update the firmware, discover the hardware, configure that firmware, register with your build system or whatever else you can imagine doing with that machine, boot into your OS deployment, and go from there. Here we have some links. Once again, this slide set will be available up on SlideShare, and the next slide will have a link to my blog, which will have the link to all of this stuff. So if there's one thing you want to write down, it's that very first one up there. I'll have a new post here shortly, assuming the network is functional. And these are my other contacts areas. I do some Puppet modules. As you might have seen the VMware module that was on the blog post, and that was my doing. Any questions? Yes, sir.
So you mentioned when you're capturing the BIOS configuration, it is saved into XML file. I'm talking about contract.
For the HP version, yes.
Yeah. Contract. So why not doing this? It doesn't seem like you do the comparison to figure out if you actually need to apply the configuration or not. So I mean that's going to save some time, right? So
possibly
2 or 3 minutes at least.
The firmware updating piece is what takes the longest in that. The flashing of the firmware, bam, it's about a second. Or not the flashing, the configuration. So for us, it's just easy to apply it instead of trying to do a comparison.
So you do firmware update regardless, and then you configure it.
Correct.
That's basically it.
Yes. It's flexible to do whatever you need to. I'm horrible with XML, so I just figure Toolkit is what it's called.
Does it have the same capabilities?
For the most part, yes. The example configs aren't quite there, but if you read through, I've got some example blogs of installing these tools and getting them up and working for you up at the up on my blog there. You'll be able to try and, I've basically built my Dell toolkit similar to the HP one, taking lessons I've learned from there and applying them to the Dell toolkit.
And you don't mind which Dell models you would use?
I was evaluating the C series that came out.
DCS?
The cloud hardware, C2100, C1100s. They've come out within the last 8 months or so. It's the lower end. It's not their PowerEdge R series machines.
Okay.
How much time do you spend maintaining your own script? Obviously, when you get new hardware, you have to add some case.
Yes.
But other than that, it just
Once we've had it set up, it took a lot of upfront development
Yeah.
time, learning and whatnot. But after that, it's just a matter of new hardware comes out, capture the configuration once we get it to where we want it, save it, and then all the rest of the machines. It's very little time, a couple days, just evaluating the new hardware.
and then you spend some significant amount of time looking at the logs afterwards, or
Right now, with our Hadoop clusters, our hardware platforms haven't changed. Same thing basically, so we don't really look at them all that much. That is on the to-do list. Once we roll this out more into the enterprise, we'll want to make sure that we're capturing errors and tracking things. Any other questions? Yes, sir.
I mean, we'll do doing the same kind of setup for sort of updated machines that have already been built to deploy out into the environment, and you need to, get a whole firmware updated.
There is a possibility with that. I know with the HP tools, you can install them on supported operating systems. So they have an RPM of these tools themselves that'll be deployed on Red Hat. You could, apply a BIOS configuration at that point. All you would need to do is reboot. So that is a possibility, but we haven't really looked at doing that particular thing.
Well, then you could also just reboot the system and boot it into this. It's just you gotta make sure that when it reboots, it still comes up with the new firmware. So that's another option too.
Yeah. Yeah, so definitely if you are also flashing from a running OS, of course you have to reboot for that to take effect. And you can also then roll in the firmware configuration at that point.
But for HP at least, they already have essentially executables that you can run on the system stuff they can BIOS. All you need to do is reboot.
Yes. So we haven't quite gone down that road, but there are definite possibilities, and I could envision Puppet doing some of this stuff as well. It's just that, how do you schedule that reboots? Do you let Puppet do it? Those sorts of questions. The sky's the limit, pretty much.
There's that schedule attribute for all resource types.
That is correct.
Or when you schedule, we just do that.
Okay. So that could be an option as well.
Yeah. Firmware, I'm sorry, but other things as well.
All right. Are we on schedule at this point, or?
Next speaker should be coming in shortly, but we got time for another question or two if you don't have them.
All right. If no other questions, I'll be here, but thank you all very much.
thank you.